Hello, I'm Dr. Chad McGee again, and this is another episode of Fun in Quantum Physics. Pursuant to the previous segment that we did on light and how it forms electrons, I thought today we would go into a little bit about neutrinos, quarks, and how those make bigger particles. Okay, so let's talk about what's a neutrino. Typically we think of neutrinos as a somewhat quasi-matter form. There's both the matter and the antimatter form of it. Generally they are produced in certain beta decays. Typically when you have either a W plus or a W minus boson, they'll either convert and make either an electron or positron, and then you get either the antineutrino or the neutrino, depending on which form it is. One thing that's interesting about it is they don't typically interact with matter. For example, remember last time we had talked about my symbolism that is an electron. When you're looking at the electronic part of the electron, that would be this, and of course the magnetic form is another loop around it, and of course this is not static, it's always constantly fluctuating, moving, therefore it looks like a solid ball. The antimatter form to this is this. So this would be your positron. Now, correspondingly, we know the W minus particle ends up giving us an electron plus an anti-electron neutrino. All right, and the W plus boson is going to give you a positron plus a electron neutrino. All right. So correspondingly, what does it look like? All right. Now my aspect is looking into this. I see both the anti-electron neutrino and the electron neutrino. They're going to have the same geometry, but of course, whether it's the anti-form or the regular form, it depends upon the flow of the net momentum vector. In the case of an electron neutrino, because that's going to act kind of like a piece of matter, although it's not fully appreciable to all the properties, it's going to have this type of directionality. An electron neutrino, anti-electron neutrino, is going to have one that's this direction. Now, why do I say this? Okay? Because if you were to take an electron neutrino and an anti-electron neutrino and have them interact with each other, they would go through a process called annihilation. Okay? It's simply put, an annihilation event would occur, E equals mc squared, Einstein's famous equation. In this particular regard, your matter and antimatter go back to the original material that they formed. In other words, they go back to electromagnetic radiation. So in this aspect, we are going to be basically forming the individual particles for this guy, and this guy too. Okay? And that's fairly easy to see. If these crash together, you end up going to have a light wave coming this way and a light wave going that way, 90-degree angle of incident to the interaction point. So basically, in a nutshell, you're going to get off light. So I can see where this could very easily unravel if it hits another piece that's exactly equal to it, but in opposite direction. Okay? So in a nutshell, that's what I'm saying the geometries of an anti-neutrino, electron neutrino, and electron neutrino. Now there are other forms of neutrinos, but I think that actually plays into the length of the light wave that creates these. In other words, the longer the piece of light wave that is, the more energy it requires to make it. Okay? Now this leads into something kind of interesting, and that's called gluons. Gluons are very similar to neutrinos, except they have part of it stuck to a piece of matter. So in other words, you can think of a particle like this with a gluon. To me, that's the interaction. So this would be, let's say, one that was stuck to an electron that you could have a gluon potentially sticking to it. Now, I'm not saying it's going to stick to this particular one, but I'm just going to show you that a gluon is something that can interact with another particle. So let's say that it sticks with you, okay? So that glues the things together. Conversely, they have a relationship with neutrinos. If they break off, potentially that might be one way that we form certain types of neutrinos. Okay, so that is what I classify as a gluon, and technically, yes, you potentially could have an anti-gluon, but that's a whole other ballgame. Now, conversely, let's get to something that's a little more difficult to display, okay, and talk about, and that's quarks. In particular, we're going to be talking mainly about up and down quarks. Okay? Now, conversely, remember, an up quark has a charge of plus 2/3. A down quark has a charge of negative 1/3. Okay? Well, it took me a long time of thinking about this to get the pieces to fit for a geometry on these. But I think I've come up with a relationship. And that is, an up quark has a coil that has 3 outside parts to it, 1 inside part, and it links like this. Okay? So the net effect is 3 minus 1 over 3 equals to a charge of 2/3 positive. Okay? Notice that my directional is down. Okay? If I do the opposite form, okay, so now we're going to go in anti-up quark. This is going to be not a positive 2/3, a negative 2/3. Okay? If we were to look at that geometry from that, what we should get is it should actually go like this. Notice that the flow characteristics are different. So even though it looks like they're the same, they're actually not. They're actually going the opposite direction. And so we can actually, because we have reversed the flow, there's a negative part to that. That's 3 minus 1 over 3, okay, which ends up getting us to 2/3. Okay, so net effect is outside coil minus inside coil divided by outside coil number. And that ends up, whether you're doing clockwise or counterclockwise, that's whether you have a plus or minus here. Okay, so that's the geometry of an up quark and an anti-up quark. Now, down quark is going to be a little bit different. Okay, so you have your 3 loops, 1 inner loop, 2 inner loop, and then here you go. Okay? So if you do that, you end up with a negative 3 minus 2 over 3. Okay, that gives you a total of minus 1/3. Okay, so that's your geometry. You have basically a spiral up with 3, and then 2 inner ones, and then it comes back. Okay, for an anti-down, now we're going to be going opposite direction. So we're going to go 1, 2, 3, back 1, back 2, up. Okay, so you have 3 outside, 2 inner ones, and then it links back up. And it's opposite direction for that. So because of that, we go positive 3 minus 2 over 3 equals to 1/3 positive. So that is why we have the up and down and the anti-forms of these being partially charged. It's not a full charge because we don't have complete, you don't have one whole complete set, is what you could say, of coils that overact over each other. You only have partial coils for this net effect. Okay? All right, so That being said, I'll let you mule about that for a little bit, and we'll come back for another video. So I want to let you guys think about this, and we'll come back to another video on it. Thank you.